Morning students, welcome to the Science 1 class. In the previous video, we have learnt about EMF, potential difference, resistance, electric circuit and types of current. Today's class, we are going to discuss effects of electric current. When current flows in a circuit, it produces various effects, that is, heating effect, chemical effect and magnetic effect. Now we are going to discuss heating effect of electric current. Let us perform an activity. Take an aluminium foil and cut an arrow-shaped strip from it and place it on a wooden board. Notice that the edge of the aluminium foil should be sharp. Now take 9V DC cell. The cell consists of two terminals, positive and negative terminals. Take two wires and connect one wire to the positive terminal of the cell and the wire connected to the negative terminal of the cell. Two ends of the wire are connected with pins, so press one pin onto the pointed edge, that is the sharp edge of the aluminium foil, and press the other pin about 1 meter away. What do you observe? Tip of the aluminium foil starts melting. Why it is so? What's happening here? The electrical energy is converted into heat energy, which is called as Joule's heating. And this effect was first studied by the scientist named Joule. In order to honor him, this was named as Joule's heating. When the flow of current is resisted, heat is produced. By using this principle, some electrical appliances like iron box, electric toaster, electric heater, these all works on the principle of Joule heating. So even the connecting wires become warm when they are connected in the electric circuit. It is because connecting wires also offer small resistance to the flow of electric current. So they become warm when they are connected in the electric circuit. And this is about heating effect of electric current. Next, effect of chemical effect of electric current. And here also we are going to perform an activity. Take a beaker half full with copper sulfate solution. Now take a carbon rod from used dry cell. Where we use dry cell? In TV remotes, calculators, cameras and clocks, etc. Here we use the dry cell. So take a carbon rod from the used dry cell, then take a thick copper wire and flatten it with hammer. Now immerse the carbon rod and copper wire into the copper sulfate solution. Now connect the carbon rod by means of wire and connect it to the negative terminal of the electric circuit. Now connect the copper wire to the positive terminal of the electric circuit. Wait and watch. After some time, you can see the fine copper get deposited over the carbon rod, and this process is called this electroplating. So electroplating is the chemical method by which one metal get deposited over the other metal by passing electric current. So when you pass electric current through the electrolyte, electrolyte means the solution which conducts electricity. Here the solution is copper sulfate solution. It is said to be an electrolyte. So when electric current is passed through the electrolyte, what happens? Chemical decomposition takes place. And the thick copper wire reacts with copper sulfate solution, and the carbon rod also reacts with copper sulfate solution. So the copper wire loses electrons, it becomes positively charged. This is called anode. Carbon rod gains electron and it becomes negatively charged, which is called cathode. And chemical reaction takes place here. Already we have discussed the flow of electron constitute electric current. Here both the electrons and positive copper ions conduct electricity. So the process of conduction electricity through the solution is called electrolysis, and the solution which conducts electricity is called as electrolyte. So the positive terminal is said to be anode. Here the copper wire is said to be anode and the negative terminal is said to be the cathode. A carbon rod said to be cathode. Extremely weak electric current is produced in the human body due to the movement of charged particle. It is called synaptic signal, and this is due to the electrochemical process and the travel between the brain and organs through the nervous system. Next one is about magnetic effect of electric current. When the current is passed through the electric wire or a conductor, it produces magnetic field around it, and that is called magnetic effect of electric current. It was observed by scientist named Oersted in the year 1820. Oersted did simple experiment. He made a simple circuit and he kept a magnetic compass needle near the circuit. When the switch is off, no current flows through the circuit and there was no deflection in the magnetic compass needle. When the switch is on, the electric current passes through the circuit and there was a deflection in the magnetic needle. So from that he concluded that the current carrying conductor produces the magnetic field around it, and that was about Oersted experiment. So the direction of magnetic field can be found by right hand thumb rule. What is right hand thumb rule? Place thumb of your right hand in the upward direction. It denotes the direction of the current. So current is in the upward direction. You curl the four fingers in this direction. So the magnetic direction of magnetic field is in anti-clockwise direction. The current is flowing in the upward direction in a wire, then the magnetic field will be in anti-clockwise direction. This is about right hand thumb rule. So determine the direction of magnetic field. We can do an activity. Take a cardboard and make a hole center of the cardboard. Now insert a straight wire inside the hole. Connect the ends of the wire to a circuit which consists of a battery, key, ammeter and sprinkle some iron fillings around the wire. When the switch is off, no current flows through the circuit and there is no specified pattern in the iron fillings. But when the switch is on, what happens? The electric current flows through the circuit and the iron fillings forms a specific pattern. That is, they form connecting concentric circles around the conductor. So it shows that this current carrying conductor produces a magnetic field around it. Next topic is about advantages of AC over DC. AC means alternating current and DC means direct current. So the voltage of AC can be varied by the device called transformer. Transformer is a device which converts high voltage to low voltage and low voltage to high voltage. So there are two types of transformer, step up transformer and step down transformer. Step up transformer carries the current over the long distance, that is from the power station to the cities. The loss of energy while distributing the current in the form of AC is very less, and it is easily converted into DC, which device is used to convert AC into DC. It is the rectifier, and generating AC is very easier than DC. So AC, that is alternating current, in generate thermal power station and hydroelectric power station. When windmills generating AC is more easier than DC. So AC can produce electromagnetic induction and it is used for various work. What is electromagnetic induction? Magnetic effect of electric current. We have discussed that current carrying conductor produce a magnetic field around it. Electromagnetic induction is the reverse of Oersted experiment, and it was performed by the scientist named Michael Faraday. So Michael Faraday, he said that when there is a change in the magnetic field, current is produced. So electric generator works on this principle of electromagnetic induction. Next one is advantages of DC. So electroplating, then electrorefining. Electrorefining is the method to use the remove the impurities from the metal. Then electroplating, these all methods use DC, and electricity can be stored in the form of DC, and this are the advantage of DC. Next topic is in the lesson is about dangers of electricity and precautions to be taken. Damage insulation. Do not touch the bare wire. Use safety gloves and stand on insulating tool or rubber slippers while handling electricity. Overload of power circuits. Do not connect too many electrical devices to a single electrical socket. Inappropriate use of electrical appliances. Always use the electrical appliances according to the power rating of the device, like AC point, TV point, etc. Environment with moisture dampness. Keep the place where there is electricity out of moisture and wetness, as it will lead to leakage of electric current beyond the reach of children. The electrical sockets are to be kept away from the reach of little children who do not know the danger of electricity. That's all for today's class. Thank you, students. Have a good day.